So this one is January 2019 paper. The first question, hydroxide has a total 9 protons. How many neutrons and electrons are there in this ion? As you can see, there is a negative charge and -1 is there. So it means it should have one extra electron so that the overall charge should be -1. So when we check the option, if 9 protons are there, to have a net charge or overall charge of -1, there should be 10 electrons. So that's why B is the right answer. A sample of silicon contain the following isotopes, the percentage abundance of each. So how from the percentage abundance, how we can find the relative atomic mass? So percentage multiplied by mass, or mass, this is 28 multiplied by percentage 81.21, plus this one is 29 multiplied by 14.10, plus the percentage and the mass, and then divided by the total sum of the percentage, so that because the total sum of percentage should be 100, so that is divided by 100. So the answer will be 28.2. So B will be the right answer for this. Which is electronic configuration of a carbon in a ground state? So we have carbon. Carbon is basically 6 and 12. So 6 electrons or 6 protons are there. So what will be the electronic configuration of a carbon? It will be 1s2, 2s2, 2p2. So 1s it will have 2 electron, 2s it will have 2 electron, and 2p also it will have 2 electron. That is in a ground state. In excited state, like one of the electron basically jumps from 2s to 2p, and then it will become 1s2, 2s1, 2p3. This is in excited state. But in a ground state, when it is not involved in the bonding, it is 1s2, 2s2, 2p2. So when the two electrons occupy the p orbital, like 1s will have 2, 2s will have 2, and 2p, when the electron occupy first, they will occupy each as a single. So 2px will have 1 electron, 2py will also have 1 electron. That's why for question 3, D is the right answer for this. If the same question was there and they are in excited state, the same question, they are excited state means when it is involved in the bonding or trying to form a bond, then in that case, B should be the right answer. But as a ground state, when it is not involved in the bonding, so D is the right answer in that case. What is the maximum number of electron in 3p subshell and in the third quantum shell of an atom? So maximum number of electron in 3p subshell, that because subshell they are asking, not orbital. If the same question was there, p orbital, maximum number of electron in any orbital, even it is a s orbital, p orbital, d or f, orbital maximum number of electron in each orbital too. But when they ask for subshell, so subshell S maximum can have 2 electron, subshell P maximum can have 6 electron, subshell D maximum can have 10 electrons, and subshell F maximum can have 14 electrons. This is the distribution of electrons in the subshell. But in the orbital, it will always be 2. So the first they are asking, how many electrons can be there in P subshell? So how many electrons can be there? So either C can be an answer or D, because 6. Then maximum number of electron, the first shell where n is equals to 1, the first shell maximum can have 2. The second shell, maximum it can have 8. The third shell, maximum can have 18 electrons. So D is the right answer for this. The first six ionization energies of an element in kilojoule per mole are shown. Which group in the periodic table this element includes? So when there's a like big jump is there between the ionization energy, we identify that the shell changes. So 578, it is about 1800, then 2700, and then there's a big jump. There's a big difference. So it means how many electrons were there in the last shell? So it means 3 electrons were there in the last shell, or 3 electrons are removed from the last shell. So 3 electrons are removed from the last shell. Which group it belongs to? It means it belongs to group 3. The diagram shows the first ionization energies of the element from sodium to silicon. What is the approximate first ionization energy of phosphorus, which is having atomic number 15 is given. Look, this is group 1, like 11 is sodium. So this is group 1, group 2. So group 1 and group 2, why? Then when we move to group 2 to group 3, there will always be a jump. What is the reason for that jump? The orbital changes. So when orbital changes, more shielding effect is there. That's why smaller ionization. Then this will be group 4. And then group 5 will have, so it will follow a trend. So group 5 will have more. And if it was a group 6, like another element is there from group 6, then it will be smaller. Why? Group 5 and 6, what is the reason for difference? Group 5 means P3, so singly the electrons occupy the orbital, whereas group 6 means P4, that there is a pair of electron in one of the orbital, it will have more repulsion. That's why it will be easy to remove electron. So they're asking for group 5, so it should be higher. That's why D is the right answer. Which of the following dot and cross diagram for magnesium chloride? Only outer shell electrons. So magnesium, basically magnesium chloride is an ionic compound. Ionic compound is formed by complete transfer, so it cannot be A or B. Then the formula for magnesium chloride, magnesium is +2 valency, chlorine is -1. So it will be MgCl2. Here valency is not given correct for magnesium. So D is the right answer. Metallic bond is strong electrostatic force between. So the metallic bond, basically, it is a strong electrostatic force of attraction between the positive ion and the delocalized electron. So when we check the options, anion and cation, and the force of attraction between anion and cation is known as ionic. Atom and delocalized electron, that is not the force. It is an ion and the delocalized. So, and what ions, basically, they did not specify here, but it is a positive ion and the delocalized electrons. So when we have a lattice of a positive ion and the free delocalized electrons are there, they have attraction, and this is called metallic bond. So C will be the right answer. And two nuclei and a shared pair of electron, that is actually definition of covalent bond. In question 9, the ionic radius of aluminum, which is +3, is smaller than nitride. So they are isoelectronic because aluminum loses 3 electron. Aluminum is having 13, loses 3, so 10 electron. Nitrogen is having 7, it gains 3, so 10 electron. But in case of aluminum, 13 protons are attracting. In case of nitrogen, only 7 protons are attracting. So why the aluminum is having a smaller ionic radii as compared to nitride ion? So it has more protons, so more attraction is there. That's why C is the right answer. So more proton and same number of electron, because they are isoelectronic. Isoelectronic means they have the same number of electrons. Which ion has the greatest polarizing power? Polarizing power is a tendency of a positive ion to attract the electrons from the negative ion or towards. So it cannot be negative, the polarization A and D cannot be an answer because they don't have a they are polarized by a positive ion. So we are left with B and C. For higher polarization power of a positive ion, its charge should be more and its size should be small. So B is the right answer for this. Which species is not tetrahedral? How to identify the shape? You have to check the number of the bond pair and the number of lone pair. Tetrahedral means they should have 4 bond pairs. And there should be no lone pair. In carbon tetrachloride, when we draw the structure of a carbon tetrachloride, CCl4, so there are 4 bond pair, so it will be tetrahedral. CH4, carbon share 4 electrons, each one with each hydrogen. So again, 4 bond pairs, so it will also be a tetrahedral. ICl4, iodine is group 7. So how many electrons it will have? It will have 7 electrons. 1, 2, 3, 4, 5, 6, 7. Then there's a charge of -1. So iodine gain 1 electron. So it get a negative charge. And according to a question, this is ICl4. When we draw the structure for ICl4, so iodine is a central atom. Chlorine belongs to group 7. And iodine also belongs to group 7. Now to gain the stability, because if chlorine is sharing 1, iodine example share 1 from this side. So iodine shared 1 from this side. Chlorine is sharing 1, iodine share 1 from this side. Chlorine share 1, iodine share 1 from this side. And chlorine share 1, so iodine share 1 from this side. And overall number of electrons for iodine are 7. So 1, 2, 3, 4, 5, 6, 7. And 1 electron this iodine took from any other molecule. So that is a structure of ICl4. So when we check the number of the bond pairs and the number of lone pair, and for elements like such as like sulfur is there, so some of the element can adjust more than 8 electron in the outermost shell. When the atoms are large, like the size of the atom is big, it can adjust more than 8 electron even though it's a non-metal. So these are the 1 pair of electron, 2nd pair, 3rd pair, 4th pair. So 4 pairs are there and 2 lone pair, like 4 bond pairs are there and there are 2 lone pairs. So due to the presence of 4 bond pair and 2 lone pair, it won't be tetrahedral. But in NH4, nitrogen is there, loses 1 electron, so it will have 4 electron now, and it share 1 with each hydrogen. So in NH4 or ammonium ion, 1, 2, 3, and 4 bond pairs, and there's no lone pair. If 4 bond pairs are there and there's no lone pair, it will be tetrahedral as well. So all these like option A, B, and D are tetrahedral, but C is not a tetrahedral because it contains different number of bond and lone pairs. Members of a homologous series alkane have same. Like when we have alkane, what they have same. So they have the same general, they don't have same boiling point because they will have different number of bonds, different number of bond within the molecule. They don't have the same density as the number of particles are different. An empirical formula of alkenes is same. All alkenes have the same empirical, not alkanes. Then what is electrophile? Electrophile means it is attracted towards the electron rich side, because electrophiles refers to that electron loving group. So they are attracted towards the electron. So electrophile, what they always do, like if we remember reaction of alkene, electrophilic addition reaction. So if we have H and Br, hydrogen is partial positive, bromine partial negative. Bromine will break the bond, and this hydrogen is attracted towards the double bond electron. So this hydrogen is called electrophile. So what they do, the electrophiles tend to accept electron or attract it towards the pair of electron. So A is the right answer for this. Then what is the total number of structural isomers of C6H14? So how many isomers we can draw for this C6H14? So 6 carbon atoms are there. We can draw them in a straight line. Then we can make branches like 5 in a ring, then branch with the second one. Then we make a 5 in a ring and then branch with a third one. Then if I put a branch next, then it is same. Then we can put 2 branches. So 4 are there. We put 2 branches in different, or we put 2 branches on the same. So 1, 2, 3, 4, 5 are possible. Then I try to rearrange. I cannot make, like example, if I try to make 3 here and 1, 2, 3. So total, it does not make difference. Like it will be same as this one. So how many structural isomers we can draw? We can draw possible structural isomers are 5. So B will be the right answer. Like first it will be a straight chain, then with a 1 branch changing the position of a branch, then 2 branches on different, or 2 branches can be on the same carbon. Question 15, what is the systematic name of compound X? First, we have to check the heavy group, like this is CH3, this is CH3, this is H. So when we check the heavy group, this CH3 here, and this Cl is a heavy group. So when heavy groups are on the different side, so it will be E, because it cannot be cis. So any option with E is correct. And then how to name a compound? We start the numbering. Numbering should start from a nearest double bond. So 1, 2, 3, 4. Like if I count from here, second position, I have a double bond and branch. But if I count from here, 1, 2, 3, 4, second position, I have a double bond, and third position, I have a branch. So which numbering I should follow, where the double bond and branch? First, we'll check the double bond, but both ways double bond with the second carbon, the second priority is a branch. So I should follow from right to left so that the branch is with the second carbon. So it is first E is there, second position we have a chlorine, so 2 chloro, bute because of 4 carbon bute, and 2 ene because second, between second and third carbon or second position we have a double bond, so it is bute 2 ene. Then ethene react with hydrogen in the presence of heated nickel catalyst to form ethane. Which type of bond are broken and form in this reaction? So always remember, whenever like we have, there is a double bond is there, 1 sigma, 1 pi. Triple bond is there, 1 sigma, 2 pi. And the pi bonds are weaker bonds, so pi bonds can break easily. So the pi bond will break. And because hydrogen and carbon are forming a single bond is always a sigma bond. So pi bond will break and the sigma bond will form. So B will be the right answer. If there was a double bond formed, then it will be sigma and pi. Both of the bonds will be formed. But whenever there is a single covalent bond, it is always a so whenever there is a single covalent bond, it is always a sigma bond. So which type of bonds are broken? But we have to check this because here the bond which is broken, that is, it is having one sigma, one pi. So here pi bond is broken, but there is also H2. H2 means hydrogen and hydrogen. So that will have a sigma bond. So it means the bond broken will be sigma and pi, and the bond form is only sigma. Because you have to check all the reactants. Not, I was checking only first alkene, but there is hydrogen as well. And within the hydrogen, there's a sigma bond. That's why sigma and pi are broken, because here hydrogen H2 is there, so that bond broke. And here's a pi, so that bond break. And as a result, hydrogen and carbon will form a bond, so that will be a sigma bond. So C will be the right answer for this. Calcium react with dilute nitric acid to form calcium nitrate and hydrogen. So what is the balance equation? Calcium is a valency +2 and nitrate is NO3 with a valency -1. So calcium nitrate will be Ca NO3 2. So calcium nitrate should have a valency of CaNO3 bracket 2. And the equation must be balanced as well. So calcium react with nitric acid, give calcium nitrate and hydrogen. Why this one is wrong? Because nitric acid formula is incorrect, calcium nitrate also incorrect. Here also nitric acid incorrect. Here calcium nitrate formula is incorrect. So A is the right answer. In question 18, what mass of anhydrous sodium carbonate is needed to make 50 cm cube of 0.0 mole per dm cube of sodium carbonate, Na2CO3? So first we have the volume and we have the concentration. So using the concentration and volume, we'll first find the moles. So moles equal concentration into volume. Concentration 0.08 and the volume is 50 divided by 1000. So it will be 50 divided by 1000 multiplied by 0.08. So this will give us 0.004. These are the moles of sodium carbonate. But in the question, we need the mass in gram. So moles equal mass in gram divided by molar mass. So mass in gram is equals to moles into molar mass. So moles are 0.004 and the molar mass relative, we have to work out. Sodium is 23 multiplied by 2, so 46, plus carbon is 12, so 58. 58 plus 16 into 3, so 58 plus 48. The molar mass will be 106. So this will be 106. So 106 multiplied by 0.004, which is equals to 0.424. So 0.424 grams of sodium carbonate will be there in a solution of volume 50 cm cube and moles 0.08 mole per decimeter cube. A sample of air with a mass of 5 kg contained carbon monoxide with a concentration of 12 parts per million by mass. What mass of a carbon monoxide is there in the sample? So the formula for concentration in parts per million, so concentration in ppm, is equals to mass of solute divided by mass of solvent into 1 million. So concentration in parts per million, that is 12. Mass of solute, we don't know, like solute is a carbon monoxide. Mass of a solvent, 5 kilogram of air. So air is a solvent here, 5 into 1 million. So we cross multiply, 5 will be multiplied by 12. So 60 divided by 1 million, we'll get the concentration. Or it's basically the mass we'll get in gram. So this will come out as 60 divided by, so it will be 6 exponent minus 5. So, but that is in kg. But all the options you can see, all the options are in gram. So we'll get a 6 into 10 to the power minus 5 kg. We have to convert into gram. So because all the options are in gram, so we have to multiply by 1000. So when we multiply by 1000, it will be 6 exponent minus 2 grams. So A will be the right answer. Then question 20. What is the maximum volume of hydrogen formed at room temperature and pressure when 0.270 grams of lithium is added to excess of water? So first, what we have to do, using the mass of lithium, we will find, this is an excess, so we don't use water. So we'll, using a mass, we'll find the moles of lithium, and using moles of lithium, we'll get the moles of lithium. We'll get the moles of hydrogen, because we need what maximum volume of hydrogen. So we'll get the moles of hydrogen using a ratio, and then multiply by molar volume, which is 24, we'll get the volume. So the formula is moles equal mass in gram, 0.270 divided by molar mass, atomic mass of a lithium, which is 6.9. So it will be 0.207 divided by 6.9 equals to 0.03. This will give us the moles. But these are the moles of lithium. What is the ratio between lithium and hydrogen? The ratio is 2:1. So if we have 0.03 moles, how many moles of hydrogen will be there? X. Cross multiply. So it will be 0.03 divided by 2. So the moles of hydrogen will be 0.015. But these are the moles of hydrogen. We need the volume. So volume in dm cube for a gas is equals to moles multiplied by molar volume, which is 25. Some questions, remember, this is molar volume at a standard temperature and pressure. But some questions, if a temperature and pressure are not standard, then the molar volume will be different. Like mass of 1 mole will be, according to question you will use. So it will come out as 0.36 decimeter cube. So A will be the right answer for this. So this was January 2019 paper from Unit 1.